In this video, I want to demonstrate the new and improved Transit Finder starting in SkyTrack version 1.5.5. The new feature is SkyTrack now has the ability to calculate a line of transit, place it on the map, and so that line of transit would show the ideal place to view particular transit. So again, a transit is when a satellite passes in front of an object like the sun or the moon, or in SkyTrack you can also calculate transits of planets. We're going to take the sun and we're going to select we can select any satellite, but we're going to take the International Space Station, and this is going to be calculated in my backyard observatory, the location. Now, it's very difficult or uncommon to find a perfect transit for right at a particular place. And so what I'm going to do is I've got this clicked here, so it'll also list down here any passes that are near to being a transit within the parameters we specify. So in this case, if ISS passes within 180 arc minutes of the center of the sun, it'll list that pass here. And we want those near transits. So here's my range of dates. I've also downloaded a current TLE file. It's important to have a very current TLE file for the most up-to-date satellite orbit information, because orbits do change and we want this as accurate as possible to find a good transit. So there it listed two possibilities. We'll take a look at this one. So here we can see that ISS comes within 124.9 arc minutes of the center of the sun. So now we're going to come over here. I've installed Google Earth Desktop, and you have two options. Either use Google Earth Desktop installed on your local computer, or you can use Google Earth Web, but it has some disadvantages, which I'll show in a minute. It's going to create this KML file then that's going to have the transit line defined in it, and we've clicked this, so it's automatically going to open up Google Earth as soon as we're finished our calculation. And there it is. It automatically zooms in. So this red line here was generated by SkyTrack, and any point on that red line, if we went to that location, we'd see the ideal transit. So my home location was right around up here, and so there the ISS was 124 arc minutes from the center, but now on this red line it's going to be right through the center of the sun. And I'm going to zoom in this area here closest to home. You can see on the reference line here we also have some reference points, and that just gives you an idea of time. So each one of these pins is 3 seconds apart. It also shows the elevation where the transit's going to occur and the cardinal direction. So zoom in here. So now what we want to do is try to pick the ideal location to set up my equipment to videograph the transit. And for instance, this highway here, 7, is pretty busy, so I wouldn't want to set up at the side of that road. So I'm going to go up here, maybe to this side road here is pretty quiet. And I can see my location there. And what I'm going to do is I'm going to drag this guy over and drop him right on the red line. And what that's going to do, it's going to take us into Street View. You can see up here there's a compass. And what I want to do, if you remember, we had to be facing south. So I want to turn that around. So now we're looking due south. And then I'm just going to move over a bit. So there's our spot. And it's actually, looks like it's going to be pretty good. We were 20 degrees up, and you can see we have a clear view here. So we don't have a tree, a building, or electricity lines obstructing our view there. You can see when I move the arrow around down here, it's showing the latitude, longitude, and elevation. And what's nice is it does show these coordinates to 2 decimal points. So very accurate. We can get right to our spot. So this is at elevation 307. So we're going to close this. And you can see when it calculated this line, it used elevation 365. And it got that from my site because that's my defined site that I set up. So if you haven't included the elevation in your site, you need to do that. But the spot we picked on the map, the elevation is 307. So it's a difference of 60 meters. And that will make a bit of a difference. So perhaps at an elevation of 20 degrees, being off by 60 degrees in our location elevation might make a difference of maybe a third to half an arc minute. So our transit, based on this calculation, and being we're at a site different than this elevation, we're going to miss the perfect transit by that small amount. Now, for the sun and the moon, that's no big deal because the radius of our moon is 16 arc minutes. So a third of an arc minute, half an arc minute, it's still going to be an excellent transit. Where it does make a difference is if you had chosen a planet up here, because obviously the planet apparent angular size is much, much smaller than the sun, and missing the transit by a third of an arc minute will probably mean ISS isn't going to pass right over the planet. But what you can do is I can put in the elevation of the site I picked on the map, and we can recalculate. So now that whole line is going to be recalculated if it was an elevation of 307. And you can see it doesn't look a lot different, but it will be different. And I think that was our spot there. Yeah, so you can see now before the line was right about here. And it looks like it's shifted down the road here about 30 meters. So it is going to be a slightly different spot. So let's take a look at the street view again. And we want to face due south using our compass up here. And you can see we might have a problem here. So now we've got trees that might be obstructing our view. But again, for the sun transit, I'm not going to worry about that. I'm just going to go down the road here because it's still going to be excellent. But let's say this was a planet and we want to be more accurate. So then what I would do is just follow the red line here of the transit. And I might take a look at this site because it looks like this road is running due south, north and south. So I probably got an unobstructed view there. So that's how you use the map. And also, if we look at the elevation for right here, it's around 309, 308. So that's going to be fine with our calculation at 307. And while we're in the neighborhood here, I'm going to show you something else of interest. So I have to get my bearings here again. So I often travel this Highway 23, and I can see from the highway. I think that's it right there. Yep. So let's go to Street View. And this is called the Elgin Field Observatory. It's used by Western University in London. Looks like they need a new paint job on the dome. But I believe they have in there a 47-inch telescope. I'd love to get a tour of it someday. The other thing I want to show you, and we'll just do it from here, is there's an icon up here that you can go into Google Maps. And let's just say this was a site that we want to view the transit from. So I can click on that and then put in my home address. And it'll give me the directions and travel time, so I can assess where I want to go based on time as well too. The other neat feature Google Maps has that you probably know already is that once you find a route, you can send it directly to your phone. So it'll send that route to the phone, and you can navigate to your site with your phone. Okay, so it created this KML file. It automatically launched Google Earth and takes that KML file in with that information. You can save this. The default is your SkyTrack folder. You can save this wherever you want. And let's just throw it on the desktop here. And just quickly calculate again. We still had that checkbox checked. This one here, so it launched Google Earth again. But you can see here it created this KML file. And if you're trying to do different scenarios, you might rename this. So let's say sun at 307 meters. I can double click that file and go right into Google Earth and display it. But the other thing I want to show you is Google Earth Web. So you don't need the local install, but it has some disadvantages, and maybe you can correct those. I haven't spent a lot of time with it. But you click Projects, New Project, Import KML file from computer, and I'm going to go to my desktop. There's a file we just created. So open that file, and it's going to look a lot like Google Earth Desktop. Same line with our reference points of our time and direction. And if I go zoom in here, I'll just take any spot here. So you can see it displays the latitude and longitude, but now it's rounded off at a second instead of the decimal points. Certainly okay again for sun or moon transit, but for a planet you want that extra accuracy. You need that extra accuracy to try to find a transit. The other thing I noticed is that we can go into Street View just like a desktop, but for some reason when I'm in Street View it doesn't draw the line, it's gone. And I don't know, I can't seem to get it back, so maybe there's a way. I haven't played with it a whole lot, but certainly I think the better option is downloading desktop. And then of course the other advantage, if you're on the road with your laptop, you can still use desktop. You don't need the internet connectivity to recheck things. So that's basically it. Again, just a reminder, even the day or the hour before you're going to go out, you might want to download the most current TLE file, redo the calculation, and double check your site, because you will see it change with time. Anyway, I hope you find this feature useful. I think it's actually a lot of fun going out and trying to chase transits.